Bismillahirrahmanirrahim. Now we'll be starting exercise 1A, page number 13. We start with the question number 1, which says, determine whether each of the following is a prime or a composite number. Prime number, composite number. What is a prime number and what is a composite number? Prime number is that number which is only divisible with 1 and itself. It means that it has only two factors. Okay, like 7 is a number, we can divide it with 1, 1 7s are 7. 7 is a number, we can divide it with 7, 7 1s are 7. There is no other number which is a factor of 7, so it has two factors, 1 and 7. Okay, it is divisible by 1 and it is divisible by itself, so 7 is a prime number. Okay, if we see 13, okay, 13 can be divided with 1, 13s are 13, okay, it can be divided with 1, 13 can be divided by 13, 13 ones are 13, it can be divided with 13, so it can be divided by 1 and itself only, there is no other number which is a factor of 13. So it has two factors only, it is divisible with 1 and itself only. So we say that 13 is a prime number. Okay, so this is the definition of prime numbers. Now what is a composite number? A composite number is that number which has more than two divisors or factors. Like if we say 4 is a number, we can divide it with 1, we can divide 4 with 4, we can divide it with 2. 4, 1 4s are 4, so 4 is a factor, we can divide it with 4, 4 is a factor, we can divide it by 2, 2 2s are 4, 2 is a factor. So it has more than two divisors, more than two factors, 1, 2, 3. So it is a composite number. Okay. Now if we talk about 15, we see that 15 can be divided with 1, it can be divided with 3, 3 5s are 15, it can be divided with 5, 5 3s are 15, it can be divided with 15. So it has how many? 1, 2, 3, 4. 4 factors, 4 divisors. So these are more than 2, so 15 is a composite number. Okay. So we explained in detail the difference between a prime number and a composite number. So if we move to question number 1, it says 87. Okay, 87 is that number which can only be divided with 1 and 87. It cannot be divided with any other number. No, we need to check it again. 1 and 87. 87 can be divided with 1. Okay. 1 8s are 8. 1 7s are 7. So 1 is a factor. 87 can be divided with 87. 87 1s are 87. 87 is a factor. If we try with 3, 3 2s are 6. 27, 3 9s are 27. 3 is also a factor. So it can be divided with 1, 3, and 87 can be divided with 29. 29 3s are 87. 1, 3, 29 and 87. These 4 are the factors of 87. It means 87 can be divided with 1, it can be divided with 3, it can be divided with 29, and it can be divided with 87. So it has divisors more than 2, so it is a composite number. So 87 is a composite number. Then we move to part B, 67. 67 is that number. This can be only divided by 1 and 67. There is no other number, no other table where you can divide 67. It cannot be divided with 3, 5, 7, 9, 4, 11, 13. Okay, so it can be only divided with itself and 1. So it is a prime number. Part C says 73. It is also only divisible by 1 and 73. Okay, it has only 2 factors, 1 and 73. It cannot be divided with any other number, so it is also a prime number, divisible by 1 and divisible by itself. Part D says 91. It can be divided with 1, with 7, 13, 91. 91 divided by 7. 7 ones are 7. We get this. 7 threes are 21. It can be divided with 13. 13 sevens are 91. It can be divided with 1. 1 nines are 9. 1 ones are 1. It can be divided with 1, with 7, with 13, with 91. So it has 4 factors. So these are more than 2 factors. Its divisors are more than 2, so it is a composite number. By this way, we have completed the first complete question, which was about prime numbers and composite numbers. Now we need to go for question number 2. It says we need to find the prime factorization and result should be in index notation. 72. You know that when we need to find prime factorization, we start dividing with 2. 2 3s are 6, 1 7 12, 2 6 are 12, 2 1s are 2, 2 8s are 16, 2 9s are 18, 3 3s are 9, 3 1s are 3. So its prime factorization is 2 into 2 into 2 into 3 into 3. If we need to write it in index notation, we divide it with 2, we got the result 36. Okay, when we divide it with 2, we got the result 36. Then we move ahead and again we divide it with 2. Okay, so we got result 18. Okay, then it will be like this. This will come like this. This 36 again we divide it by 2. We get the result 18. 36 2s are 72. 2 2s are 4, 8s are 72. Then again it will come like this. It will come like this. 18 will come like this. We divide it with 2. We got the result 9. Okay. It will come like this. It will come like this. It will come like this. This 9 will be 3 into 3. So this is the index notation. You see, when we divide with 2, so 2 into 36 is 72. Okay. Then again we divide it with 2, we got result 18. Okay, 2 2s are 4, 4 8s are 72. Then we divide by 2, we get 9. Okay. 9, 2 into 2, 4. 4 2s are 8. 8 9s are 72. Okay. 2 2s are 4. 4 2s are 8. 8 3s are 24. 24 3s are 72. So each time we get the same result, 72. So how to do it is 72 divided by 2, we got result 36. Okay. This will carry on here. 36 divided by 2, we get result 18. Okay. Then this will come like this. Okay. And this will come like this. This will come like this. 18 will be divided by 2. 2 9s are 18. So 2 2 2 9. This will come like this. This will come like this. Okay. And this came like this. Okay. And 9 was divided by 3. 3 3s are 9. Okay. So if we multiply these two, we get 72. If we multiply these 3, we get 72. If we multiply these 4, we get 72. If we multiply these 5, we get the 72. So this is called the index notation. Okay. This was question number 2, part 1. Now if we talk about part 2, which is part B, 187, we'll see the result. It cannot be divided with 2, not with 3, not with 4, not with 5, not with 6, not with 7, not with 8. We see, if we go with 11, 11 ones are 11 and 7, 18, 77. 11 7 are 18, 187. 17 ones are. Okay. So its prime factorization is 11 into 17. When we write it in index notation, we divide it by 11 and we got the result 17. So this is the only answer for this index notation. Okay. So rest of the questions we'll be doing in the next videos.